Welcome to our next video in this series looking at the human impacts on aquatic systems according to Alberta's Grade 8 Science curriculum. This time we are focused on water quality, or identifying current practices and technologies that affect water quality, evaluate environmental costs and benefits, and identify and evaluate alternatives. Introduction to water quality. Water is one of the most important resources on Earth. It is essential for drinking, growing food, cleaning, and supporting wildlife. However, keeping water clean and safe is a challenge. Many human activities and technologies can affect water quality, both positively and negatively. In this section or video, we will explore some current practices and technologies that impact water quality, look at their environmental costs and benefits, and discuss possible alternatives to improve water safety and sustainability. Current practices and technologies affecting water quality. Landfills. Landfills are places where garbage is buried. If not designed properly, landfills can leak harmful chemicals into the soil and water. Modern landfills use liners made of clay or plastic to prevent leaks. They also collect and treat liquid waste called leachate. However, older landfills may not have these protections, which can lead to pollution of groundwater. Wastewater treatment. Wastewater treatment plants clean water that comes from homes, businesses, and factories before it is released back into rivers or lakes. There are three main stages. Primary treatment removes large solids. Secondary treatment uses bacteria to break down organic matter. Tertiary treatment removes nutrients like nitrogen and phosphorus, and sometimes even chemicals and viruses. Secondary and tertiary treatments are important because they help prevent water pollution and protect aquatic life. However, these processes can be expensive and use a lot of energy. Agriculture and irrigation. Farming uses a lot of water for irrigation. Sometimes irrigation can cause salts to build up in the soil, a problem called salinization. This makes it hard for plants to grow and can harm water quality. Fertilizers and pesticides used in farming can also wash into rivers and lakes, causing pollution. Phosphates and eutrophication. Phosphates are chemicals found in fertilizers and detergents. When too many phosphates enter ponds and streams, they cause algae to grow quickly. This process is called eutrophication. When algae die, they use up oxygen in the water, which can kill fish and other aquatic animals. Water export. Some regions consider exporting water to places where it is scarce. While this can help people who need water, it can also harm local ecosystems and reduce water available for wildlife and agriculture. Each practice and technology has both costs and benefits. For example, modern landfills protect water quality but require money and land to build. Wastewater treatment plants keep water clean but use energy and chemicals. Irrigation helps grow food but can cause salinization and pollution. Exporting water can help people but may harm the environment. To evaluate these costs and benefits, we can ask questions like, does the practice protect human health? Does it harm wildlife or natural habitats? Is it affordable and sustainable? Can it be improved with new technology? Identifying and evaluating alternatives. To improve water quality, we can look for alternatives to current practices. Here are some examples. Safer landfill design. Instead of traditional landfills, we can use advanced designs with double liners, leak detection systems, and better leachate treatment. We can also reduce waste by recycling and composting. Improved wastewater treatment. Some communities use natural systems like constructed wetlands to treat wastewater. These systems use plants and soil to clean water, which can be cheaper and use less energy than traditional plants. Upgrading to tertiary treatment can remove more pollutants, but it costs more. Sustainable agriculture. Farmers can use drip irrigation to reduce water use and prevent salinization. They can also use fewer fertilizers and pesticides, or switch to organic farming methods. Note that organic farming methods still use fertilizers and pesticides. They are just restricted to a very much shorter list of allowed fertilizers and pesticides, which are more environmentally conscious in terms of production and waste. Planting cover crops and buffer strips along waterways can help filter out pollutants before they reach rivers and lakes. Reducing phosphate pollution. Governments can ban or limit phosphates in detergents. Farmers can use fertilizers more carefully, applying only what crops need. Communities can build wetlands or ponds to trap phosphates before they reach larger bodies of water. Responsible water export. Before exporting water, it is important to study the effects on local ecosystems and communities. Alternatives include improving water conservation and efficiency in areas with shortages, rather than moving water long distances. Conclusion. Protecting water quality is a complex challenge that requires careful planning and smart choices. By understanding current practices and technologies, evaluating their costs and benefits, and exploring alternatives, we can make decisions that keep our water safe for people, wildlife, and future generations. Everyone has a role to play, from governments and businesses to farmers and families. By working together and using science and technology wisely, we can ensure clean water for all. Checking for understanding. Which of the following is a common practice to improve water quality in urban areas? Building more roads, increasing industrial output, planting trees and vegetation, or reducing green spaces. Pause now if you need more time. It is planting trees and vegetation. What is the primary benefit of using tertiary wastewater treatment? It adds more chemicals to the water, it increases the speed of the water, it reduces the cost of water treatment, or it removes nutrients and pollutants more effectively. Pause now if you need more time. It removes the nutrients and pollutants more effectively. Which technology is often used to desalinate seawater to make it potable? Is it chlorination, filtration, reverse osmosis, or sedimentation? Reverse osmosis is the one we're looking for. What is a potential environmental cost of using phosphates in fertilizers? Enhanced plant growth, eutrophication of water bodies, improved soil quality, or increased crop yield. Pause now if you need more time. Eutrophication of water bodies. When evaluating the location and design of a landfill, which factor is most important to consider for protecting water quality? Is it cost of construction, distance from natural waterways, proximity to urban centers, or the size of the landfill? Pause now if you need more time. Distance from natural waterways is the biggest one. If you have any questions or feedback, please leave them in the comments and I will try to respond to them in a timely fashion.